We are now going to begin Unit 5, Lesson 1, which is on quadratic equations. So, the first unit focuses on solving quadratic equations. Let's make sure we got the title. By graphing. So before we solve quadratic equations by graphing, you need to know what a quadratic equation is. Well, first of all, we know equations have an equal sign. Quadratic equation means the exponent, the largest exponent we're going to see on the equation is a 2. So something like this, x squared. That's what we call the quadratic term. So let's start off with the standard form of a quadratic equation. Is ax squared plus bx plus c. So the ax squared is the quadratic term. This is the linear term. And this is our constant, meaning there's going to be no variable attached to it. Now, a, b, and c are just numbers. What's important here is this x squared is the quadratic, x to the first power is the linear term, and then the c is the constant. All right, so now that we know what the standard form of a quadratic equation looks like, let's go through what the solution is going to look like. So our solution, because that's what the title of this lesson says, solve quadratic equation. So the solution is the place where the graph hits or crosses the x-axis. So the place where the graph hits the x-axis. So all of our graphs are going to look like this. It's going to be a U-shaped graph. And at the bottom of our graph, there's going to be a point. We call that the vertex. Sometimes it'll be the high point. We're going to talk a little bit about that later on in one of the other lessons. But for now, all of our vertices are going to be at the bottom of the graph, our vertex. And that's really the point where the graph becomes symmetric. It's kind of like a mirror image. So, in order to graph our quadratic equation, the first thing we need to do is to find the vertex. I've got to find out that point that makes that graph symmetric or starts to turn. So there's a little formula that we use. Your teacher should have taught you this. We call it to find the x coordinate of the vertex. It's x is equal to negative b over 2a. You don't have to memorize it, but you'll be using it so much that you'll remember it. So that's going to be our first step in every single problem when we're graphing a quadratic equation. We first have to find the vertex. And then once we find the x part of the vertex, I'm going to show you how to find the y part, and then I'll show you the next steps. So, the directions are going to say graph. In order to do that, we'll say graph and solve. So in order to do that, first find the vertex. And then I'll show you the next steps. So let's take a look at number 1. Here's our quadratic equation. Y is equal to, it's kind of, well, we're going to need that formula. Y is equal to x squared plus 4x plus 3. All right. So, using the standard form that I just gave you at the beginning of the notes, here's the standard form of a quadratic equation. Ax squared plus bx plus c. All right, now I need to use this little formula which has an a and a b in it. That's where this a and b is going to come from, right from our quadratic equation. So if I take a look at this, a is the number in front of x squared. So since there's no number there, it's a 1. The b is the number that's in front of the x. There's a 4 there, so b is 4. So I'm now going to take these two numbers and substitute it into this little formula. So I'm going to take the b, which is 4, put it in, but it now becomes a negative. So it's negative 4 over 2 times 1. Taking this 1, putting it in. I've got negative 4 over 2, which gives us a negative 2 for the x part of the vertex. So I've got negative 2. Now I'm going to take that negative 2 and substitute in to this equation. Wherever I see an x, I'm going to take that negative 2 and put it in. So I'm going to lift this up a little bit. Let's do the work right underneath it. I've got negative 2 squared plus 4 times negative 2 plus 3. Let's do the math. Negative 2 squared, that's giving us 4. 4 times negative 2 is minus 8 plus 3. 4 minus 8 plus 3, negative 1. So that's the y part of the vertex. Now, from there, I'm going to get 4 other points. I want my graph to at least have 5 identified points. So, I'm going to set up a table because this is how I'm going to find the rest of my points. I'm going to write the problem in the center of my table. All right, so this negative 2, I'm always looking at the x because I'm filling in the values for x here in my table. So 2 numbers that come before negative 2. So if I think of my number line, here's my number line. 1, 2, 3, 4, negative 5. 1, 2, 3, 4, 5. I'm going to negative 2. It's right here. 2 numbers that come before negative 2 are negative 3 and negative 4. So those are going to be my first 2 values. So negative 4, negative 3, and then 2 numbers after negative 2, which is negative 1 and 0. So those are the values that I'm substituting into my table. I'm doing this because I have to graph it. So let's do the work. Negative 4 squared is 16. 4 times negative 4 is minus 16 plus 3. Let's do the math here. That's giving us 3. 3 squared is 9. 4 times negative 3 is negative 12 plus 3. Do the work. 9 minus 12 is negative 3. Negative 3 plus 3 is 0. I like it when I have zeros in my table. There needs to be a 0 for the y in my table. And you'll see once we graph it what I mean by that. 1 squared is 1. 4 times negative 1 is negative 4 plus 3. 1 minus 4 is negative 3. Negative 3 plus 3 is 0. And then 0 squared is 0 plus 0 plus 3. Notice the y values repeat. They have to, otherwise you've done something wrong. And this is going to tell me my solution. So zeros in the table are important. So let's graph it. Here are my 4 other ordered pairs. Negative 4, 3, negative 3, 0, negative 1, 0, and 0, 3. Now I'm going to move this paper over so I can kind of graph this. All right, let's go about 5 in each direction. Now I'm drawing this freehand, so they're not going to be that pretty. So let's start negative 4, 3. 1, 2, 3, negative 4. Up 3. Negative 3, 0. Negative 1, 0, and then 0, 3. And if you notice, I'm missing a point because I have to plot my vertex, which is right here, negative 2, negative 1. And here's my U-shaped graph. You've got to make sure it looks like a U. Not a V, but a U. All right, so let's see, did we answer the directions for these problems? We graphed it. Now I have to give the solution. The solution is the place where the graph hits the x-axis. Well, it actually hits it twice, at negative 3 and at negative 1. So that is my solutions. I've got two of them, negative 3 and negative 1. Okay, let's do one more problem. So this is my solution, the place where the graph hits the x-axis. Number 2. Let's see what we got. Here we go. I've got x squared minus 10x plus 25 is equal to 0. All right. The first problem had y equals. Now there's no y here, there's a 0. It's the same thing as if it said equals y. Same thing. So don't get confused if it says 0, if it says f of x. They all mean the same thing. That should be enough there. All right. First step, let's find the vertex. So I'm going to take my little formula, negative b over 2a. A is 1. B is negative 10. So I'm going to take this negative 10, put it in for negative b, so that 10 actually becomes a positive 10. And then I've got 2 times 1, which is 2. So the x part of my vertex is 5. Now I have to find the y part of the vertex. So I'm going to take this 5, and wherever I see an x, I'm going to put a 5. So I've got 5 squared minus 10 times 5 plus 25. 5 squared is 50. Well, 5 squared is 25, not 50. That's 25 minus 50 plus 25. Add that up. Is 0. So my vertex is 5, 0. Now remember, I like it when I've got 0 for my y. I'm going to put a little star next to that. Okay, so let's set up our table. We found the vertex. Now it's time to set up the table. I've got my x column. I've got my quadratic equation. I've got my y column. Now, in order to find my x values that I'm going to use for my table, I'm going to go 2 numbers that come before 5, 2 numbers after 5. Let's get rid of this star because that looks a little, we'll put it up above. Okay, 2 numbers that come before 5, 3 and 4, 2 numbers after 5, 6 and 7. So that's what I'm going to use here in my table for x. Remember, this equals 0 is the same thing as equals y. So I'm going to take those numbers and I'm going to substitute in for x. 3 squared is 9. Negative 10 times 3 is negative 30 plus 25. Let's do the math. This is giving us 4. 4 squared is 16. Negative 10 times 4 is negative 40 plus 25. Let's do the math on that. 1. 6 squared is 36 minus 60 plus 25. And I go left to right, it's giving me 1. 7 squared is 49 minus 70 plus 25. That's giving me 4. So I've got 3, 4, 4, 1, 6, 1, and 7, 4. Okay, so I've got these 1, 2, 3, 4, and this vertex that I've got to graph. So let's graph that. We'll do it right over here. Now the largest number I have for my x is 7, so I'm going to extend this a little bit more. X and y, we'll go 1, 2, 3, 4, 5, 6, 7. Our largest y will go up 5. We'll go 5 in each direction here. Okay, so let's graph this. 3, 4. I've got 4, 1. I've got 6, 1. And I've got 7, 4. And then I've got this point. I've got 4 points. I forgot to graph my vertex. I've got to graph that. That's 5, 0. I'm going to this is going to be a curve. It's not a V. All right, so we've graphed all 5 points. Now I need to state what the solution is. Where does this graph hit the x-axis? Well, it hits it right here at 5. And it may happen where there's only one solution, like it is for this one. The first problem we had 2 solutions. The second problem we had 1 solution. And that is Unit 5, Lesson 1.